So being able to do this is, I think, an important skill, being able to do degrees or radians. You can sit and watch me do it, or you can kind of work on doing it yourself, and we'll probably get to each of them as we look through some of these. We're going to talk about cosine of 225 degrees. In terms of degrees, your 200s are going to be in that zone down there, and anything ending in a 5 is going to be that middle triangle. So 225 is right there, and the 25, the cosine, well, sine and cosine are going to be the same since it's a 45-degree angle. And because it's in the second quadrant, they're both actually going to be negative. So you got negative root 2 over 2. If it were sine of the same thing, I'd have the same answer. Sine of 150, now in the hundreds, you're up here. So you have to still know whereabouts up here. 150, 135 is in the middle. And how do I know that? Well, I should know that this is 180. And I should know that 30-degree increments will get all the dots except for that middle guy. So 30, 30, and 30 get you to 90. 90 plus 30 is 120, plus 30 is 150, plus 30 is 180. That's a pattern that just kind of needs to be known. You don't have to memorize the unit circle to be able to know that that's 150 degrees. And if that's 150 degrees, well, and you look at it, it's a shorter triangle than it is a shorter triangle than it is wide on the base. So just knowing that and understanding that your answers are going to be 1/2 root 2 over 2 and root 3 over 2. If those are if those are the lengths of the sides of any triangle, you need to know that that's smaller than that, which is smaller than that. So that's the biggest, that's the smallest. There's your small side and there's your long side. Well, the sine is the vertical distance. So the short side of that triangle is 1/2. It's the shortest side possible. It's also up, so therefore that's why it's a positive number. When you say sine of 2 pi over 3, now we're talking radians. 2 is less than 3, so that means it's in the second quadrant. Denominator of 3 means it's a tall triangle. So when I hear people say long triangle, and that's sketchy because these are the same distance. So long isn't going to help you with this one or that one. That's the long side, and that's the long side. But one's the sine and one's the cosine. If you think tall and short, you know this one's the tall one because it's taller than it is wide. And if we're talking about the sine of a tall triangle, well, sine and tall, that is referring to that longer leg. If it was the cosine of a tall triangle, now you're looking for the x value, the short side. So the sine of that is the longer distance. And again, it's up, so it's a positive root 3 over 2. And now if we're talking the cosine, denominator of 4, that's always going to be that one in the middle. Okay, so this is, what do we say? It's pi over 2, or 2 pi over 3, and this is 3 pi over 4. That's this guy. Now it's the middle one. Again, it's the square root of 2 over 2 and the square root of 2 over 2. Cosine just happens to be negative in this quadrant, so it's negative root 2 over 2. You just got to pay attention to the pluses and the minuses of that. And that's, as much as you can do, that is what it is. I guess we can look at some of these trickier ones. Sine of 600, that's not a familiar zone in the unit circle. So if we subtract, 360, we should be able to get there. That would give you 240 degrees. Now 240 is just beyond 225, but not quite to 270. So 240, that's going to be that tall triangle in the third quadrant. Again, hey, bug, since it's a sine, it is the sine of that tall triangle, and therefore it would be a negative root 3 over 2 because, see, and it's showing you right there where the tall side of the triangle. Thank you, Seymour. Right? 225, good. 220. 240, 210. Sorry, he was too fast for me, but that's his expertise. Sine of 7 pi over 2. Now, we counted around there before. See you later, Seymour. That's pi over 2. That's 2 pi over 2. 3, 4, 5. Wait. I'm distracted. Yeah, that's 1 pi over 2, and that would be 2 pi over 2, which is pi. That's 3 pi over 2 and 4 pi over 2. So if you count around like that, 5, 6, 7, 8, and 9 pi over 2. Well, 9 pi over, no, it's 7. 8, 7. 7 pi over 2 is down here, so 7 pi over 2, the cosine is equal to 0. Right there, and there's Seymour, and there's Seymour. Sorry. Sine of 6 pi, there's 0, there's pi, there's 2 pi, there's 3 pi, there's 4 pi, there's 5 pi, and then there's 6 pi. It's right back here, also 0. 13 pi over 4, and it's negative. Well, again, if we're counting around in terms of pi over 4s, let's do the front way first. Pi over 4, 2 pi over 4, well, 3, 4 and 5 pi over 4. If you look at the pi's over 4 around the unit circle, it's 1, 3, 5, and 7. And so any odd number is going to be a denominator of 4. So 1, 3, 5, 7, 9, 11, and 13. And the cool thing about that is you can do it the opposite way. 1, 3, 5, 7, 9, 11, and 13. So 13 pi over 4 negative would be up in the second quadrant. Cosine is still negative in the second quadrant, so it's negative root 2 over 2. And if you thought about it, it's cosine, it's denominator of 4. The answer is going to be root 2 over 2. You could almost flip a coin and hope for the best to get it positive or negative, but you should do better than that. So there's the first one.